seminar of geological sciences between Ukraine and Spain. I'm Santiago Giral. I'm the director of the Geociencias Barcelona Institute that belongs to the Spanish Research Council. And for me, it's a really huge pleasure to open this seminar. We have today 3 talks, and this talks has been really nicely organized by Hanna Liatseva, who I'm really happy to have you here. Thanks a lot for organizing all these things. It's always interesting to hear you and doing science in these difficult conditions. So it's really wonderful to have you, all you here. Okay. And well, please, you can start, and then if you have questions, please wait for the end of the conferences, and then we will have these questions to our colleagues. Okay. Thanks, Hannah, for starting, and welcome to you all.
Yeah.
I'm glad to welcome you to the 3rd conference of the cycle Global Vision of Ukrainian Geology. I'm happy to introduce my Ukrainian colleagues and their reports. The participant of this conference, Ecological Aspects in Geological Research, is a team of researchers from leading scientists and educational institutions in Ukraine. The main direction of research are marine geology, paleontology, ecology. Alexandra Ольштинська, leader of this group, famous geologist, doctor in geology, head of Department of Modern Marine Sedimentogenesis, Institute of Geological Science, National Academy of Science of Ukraine. She is member of the Specialized Academic Council for the Defense of Thesis in the specialty Marine Geology at the Institute of Geological Science of Ukrainian National Academy. Member of the additional board of International Journal on Ecology, member of the editorial board of Geological Journal, Oceanographic Journal, Geology and the Minerals of the World Ocean Magazine. Yulia Tymchenko is a PhD in geology, is a senior researcher in the Institute of Geological Science, Ukrainian Academy of Scientists. Scientist field is paleoceanography, micropaleontology, sedimentology, and marine geology. Anna Ivanova is PhD in geology, is a senior researcher of the Institute of Geological Science of Ukrainian Academy of Science. Fields are marine geochemistry and geology. Evgen Nasyetkina is PhD in geology, scientist, secretary of the World Ocean Research Council at the Presidium of the National Academy of Sciences of Ukraine. He participated in 7 voyages of research vessels, including 5 Antarctic expeditions. And Sergei Kadurin is a PhD in geology, associated professor of the Department of Marine Geology, Hydrogeology, Engineering Geology, and Paleontology, Odessa Mechnikov National University. The first presentation is some result of oceanographic and marine geological studies of Ukrainian researchers in the Argentine island waters. Sergei Kadurin, Odessa Mechnikov National University, Alexandra Ольштинська, Evgen Насєдкін, Institute of Geological Science of the National Academy of Science. Please, Sergei, you can start showing your presentation.
Okay, thank you very much. And good morning for everybody. And let me introduce my presentation about our first preliminary results of marine geological study in Antarctica in our station. Actually, that was a former British Antarctical station called Faraday. It's located in Antarctica Peninsula. It's here is its small Argentina islands, archipelago, and in Gelindes Island, it's location of our station. Now it's our Ukrainian Antarctic station, Academic Vernadsky. And all these islands around, it's archipelago, Argentina archipelago area. And that's why that is our first point of study. And also we have that called Penola Strait between that archipelago and the main continent, Antarctic continent. So that's the second place of our study. And the main goal of our work is a study of bottom relief morphology and bottom sediments distribution within this Argentina Islands archipelago and around of all these areas. So the main task which we try to decide in that stage, it was echo sounding of bottom relief within Argentina Islands inside in our archipelago, and also echo sounding and of bottom relief between Argentina Islands and the Antarctic Peninsula in that Penola Strait, because it's quite different levels of depths between islands, and in the middle of islands, the main depth of the sea, it's nearly 50-30 meters, but in Penola Strait, it's nearly 400-300 meters. So that's why it's quite different levels and different types of sedimentation also. And also we try to understand that distribution of bottom sediments, and we make our sampling in Penola Strait, in deeper part, and also between Argentina Islands, also between these islands. And we try to decide, we study diatoms, and we try to make some conclusions about paleoecological situation in that area. So we start with bathymetrical study. So we use echo sounder, card plotter, Lawrence to understand that sampling, and you can see the map of all our points of destination and points of detection, that depths, position of depths, and after that we make, according to using GIS programs, we make that digital elevation model of underwater relief to understand that geomorphological situation under that all these areas. And also we use for sampling, we use grab sample, one win grab sample with bottom coverage surface nearly 0.1 square meter. To samples, to take samples from present bottom between the islands, and you also can see that map of sampling points between islands. As a result, we have that type of bathymetrical map in Argentina Islands archipelago. You can see in that map, we understand that there are some different, like paleo valleys, like big structures with quite high depths, nearly 50-60 meters, and also different places where the depth is less than 10 meters, less than 20 meters. So we have some differentiation according to depths directly in the middle of that archipelago. Also, it's quite interesting shape, or the main shape of all these valleys and all these depressions between islands, because mainly all these depressions has quite steep slopes and quite flat bottom, and so it allows us to understand that speciality of making this geomorphology. According to geological understanding and according to geological background, we can say that that structure, all this area has some some specialities and main structures, geological structures. First of all, it's a big fault which goes through that Pinola Strait and in another side to Limier Channel also. And that's the main fault which separate different parts of Antarctic plate at all. And also we understand that area of Argentina Island archipelago also has some fault structures and block structures at all. And all this sedimentation, all present sedimentation, it's connected with that main tectonical framework, frame structure of all this area. In another hand, during the last glacial maximum age, these large valleys were completely occupied by ice flow. And also we found that information from literature, and we found that like evidences in our study of bottom relief. So we can expect that ice erosion should make that special structure of underwater valleys. Our bathymetrical study and sampling in Pinola Strait was made from our research vessel, Noosfera. And we make that sampling using this gravity corer. And the result of bathymetrical study shows that all this Pinola Strait can be divided in two big depressions with quite high rocky ridge in the center. And actually, as you can see, even in the profile, these slopes of these underwater depressions are quite steep, and the bottom is quite flat. And we took two samples from different depressions, and we tried to study this course from these different places. These samples and these cores from these depressions from Pinola Strait. According to lithology, we can say mainly all samples it's silty mud with sand admixture and with some pieces, some fragments of rocks which can come there from surrounding islands. So in one place we have the core nearly 0.5 meters, and from another place in deeper part of Pinola Strait we took a sample nearly 1 meter, that core, 1 meter core. We use diatomic analysis to understand what we have in that area at all. And actually, we can say that 76 species of diatoms have been identified from core 362. Diatomics are widely used as indicators for modern and past oceanographical conditions, based on their good preservation potential and their frequent occurrence. Diatoms are particularly used as proxies in highest latitudes and coastal regions. The most numerous species is Thalassiosira antarctica, nearly 40%, and Thalassiosira lantigiosa, nearly 3%. Thalassiosira antarctica is divided into two species, separate varieties based on morphological types. There is a worm species with valve diameter greater than 20 microns, and cold species which valve diameter less than 20 microns. Worm species prevailed in a rate 4-to-1. Thalassocera antarctica is an Antarctic diatom associated with sea ice and low sea surface temperatures, living in waters with high concentration of sea ice, but rare in sea ice. Thalassocera lenticiosa is found in almost all samples. Maximum abundance of Thalassocera lenticiosa species are found with winter age of the sea ice maximum. Evcampia antarctica is common in many Antarctic regions and in the Southern Ocean at all. The distribution of Evcampia antarctica is associated with a neritic environment with the presence of floating ice. The increased occurrence of Evcampia antarctica might be regarded as an individual indicator of relatively warmer climatic conditions with prevailing stratified water columns. The genesis Fragilariopsis includes 4 species. Fragilariopsis kerguelensis is considered endemic in the Southern Ocean waters and often dominates in complexes of the open ocean zone south to the polar front. Fragilariopsis curta occurs commonly in ice age and in meltwater stratified water layers associated with retreating sea ice. Such characteristic species as Paralia, Actinocystus,
Ukrainian geofeedback.
Adonella ligiosa и Adonella vivlogi are found in negligible amount through the section of the core bottom sediments. Penola Strait sediments contains a large group of species of genesis Coconace. Coconace species genesis are included in epiphytic associated and are associated with sinking of mussels and macroalgae. And also you can see other detected diatom species from Penola Strait bottom sediments here on that slide also. And as first our preliminary conclusion, we can say that we start our work in these years, and we expect that we prolong that work in the next years also. And in that time, we can say that we found different geomorphological situations and geomorphological environment situations in the bottom. And we found and we detect areas where we can expect quite high amount of present accumulations. And also we understand for us, we understand the structure of Penola Strait. We understand that Penola Strait, it's in one side, it's an area of main fault structure in that area. And in another side, it's also the place where was a big glacier in the last glacier maximum. And also combination of all these two processes and tectonical process and also ice glacier erosion and ice glacier sedimentation is also combined in one place in one Penola Strait. And also quite it should be somewhere presented in thickness and in sequence of sediments, marine sediments. And also we found a big amount and big distribution of microfauna like diatoms. And now we found different species. We found some distribution of these species, and now we study this diatoms, and we try to make some understanding, some paleoecological reconstruction based on this study of diatoms. And now what we can say in that stage, we can say that according to this distribution of diatoms, we have sea ice, and we have some distribution of sea ice in that area, and that's why we expect we will take in the future, we will take a bigger course and can make our interpolation in geological history along there. So thank you for your attention.
Thank you very much, dear Sergey. Maybe I suggest to start the discussion after listening of the all reports. Okay?
Okay.
Thank you. Muchas gracias.
Thank you. Thank you. Thank you.
The next speaker is Anna Ivanova. Monitoring of suspended matter within Zaporizhia region, the main trends. Євген Насєдкін, Олександра Ольштинська, Анна Іванова, Institute of Geological Science of the National Academy of Science of Ukraine. Please. Анна, ми вас не чуємо. Ага, все. Давайте.
Okay.
Так.
Good day, dear colleagues. Let me first thank the European scientific community for supporting Ukraine and Ukrainian science in the most difficult time for our country. We really appreciate and feel your support. Thank you for your opportunity to make the presentation in this meeting. My presentation is monitoring of suspended matter within the Zaporizhia region, the main trends. It was worked up in Department of Modern Marine Sedimentogenesis of Institute of Geological Science of National Academy of Science of Ukraine. And this work has ecological direction. In geological history, exogenous processes have played a huge role in the formation of Earth's surface. Transport of sedimentary matter by air and water flows, along with the natural mechanism, played one of the main role of this process. But today, the natural mechanism of transit of sedimentary flows acquiring a negative content because it can carry substances of various technogenic process in the atmosphere and aquatic environment. Let me say that we began our work 19 years ago, and the first monitoring point was organized on the basis of a oceanographic platform which belongs to National Academy of Science of Ukraine in the Black Sea. It's situated 400 meters from the southern bank of Crimea. So you see how we organized our monitoring observation. We installed two types of sediment traps on the oceanographic platform. In the desk, we installed the traps for sampling the solid component of aerosol for vertical and horizontal airflows. And in the bottom column, we were settled two sediment traps for suspended matter. I don't stop on our results because in 1940, after annexion of Crimea Peninsula by Russian Federation, we lost the opportunity to continue our observation, and it was decided to reorganize observation point in another region of Ukraine. We chose this Zaporizhia region. Why Zaporizhia? Because Zaporizhia occupies a leading position in Ukraine among industrially loaded meteorological centers. Significant concentration of enterprises of ferrous, non-ferrous, metallurgy, the mechanical engineer is situated here. It causes in some areas of the city an intensity emission of number of microelements into environmental, including iron and heavy metals. So you see where our monitoring point is situated, and this is the districts where the enterprises are concentrated. The new research is aimed at studying the quantitative and qualitative characteristics of the substances of atmospheric and river flows within this area. Scientific tasks included monthly observation, monthly sampling of solid component of aerosol, river suspension, single samples of ground sediments and bottom sediments. Then we made geometric, mineralogical analysis, investigate trace elements, chemical composition of the samples, microprobe analysis. During our study, we took into consideration meteorological parameters as wind velocity, wind directions, duration of these winds, and the days with precipitations. Then the results are passed to the database worked out in the base of our department. During our study, we use two types of sediment traps. First is the sediment traps for suspended matter in aquatic environment, and the trap for solid component of atmospheric aerosol. We used them on a iconographic platform, but in Zaporozhye we make upgrade of this equipment and obtained Ukrainian patent for this. We installed these traps in the base of Hydrophysical Center of National Academy of Ukraine. This is aerosol trap, and this is a set for suspended matter. So some of our results. You see the typical component is the same image as the typical component of aeolian substances. This is the fragment of quartz grain, debris of feldshare grain, plant pollen. But if you look at the general image, you can see the significant number of spherical formation, which we determine as anthropogenic. This is the image of big spherical formation, small spherical formation. There are two components of two types of anthropogenic spherules. First, it's iron spherules, and these iron spherules are the most common anthropogenic component in the environments where their enterprises are situated. We found them not only in the solid component of atmospheric aerosol, but in the suspended matter of Dnieper River, but also in the bottom sediments, in the river drifts, and other. These heterogeneous or iron spherules are particularly unstable to environmental factors and exposed to decomposition process, especially in the river environment. Oxidation and other changes in such formation can affect the ecological state of the environment, since some of toxic elements are able to go into the ionic state, forming the composition of natural water. The second category of suspended matter component is aluminosilicate spherulas consisting of aluminum oxide. They are also potential results of high temperature process of human production activity. It's thermal power operation, metallurgical, and other related industries. The mineral composition of these spherules, approximately 70%, is represented by aluminosilicates with an admixture of irons and sometimes microimpurements of heavy metals, mostly zinc and copper. The average size is from 1 to 20 microns, but individual spherules can reach 50 microns. One of the features of this aluminosilicate spherule is their discontinuous structure. They are usually hollow inside, and they differ from iron spherules. We call them cenospheres, and their formation occurs at the part of the fly ash in the furnace of thermal power plants and in hydroelectric plant during high temperature burning of coal. During the combustion of finely divided coal particles, impurements of silicates, which take a spherical shape in the molten state. Due to the gases dissolved in the silicates, such as nitrogen, oxygen, carbon dioxide, spherical microdrops of molten silicates blow up into such microspheres. The third component of the technogenic origin is river suspension of river, and air suspension is clastic fragments of iron oxide. It's represented by a significant range of dimension from 5 microns till 70 microns. These metal-bearing grains contain microimpurements of different metals such as copper, chrome, nickel, titanium, zinc, and others. According to microprobe analysis of its chemical composition, content of iron oxide can exceed 19%. It's the second or the third component of technogenic original is river in this is the presence in this suspended matter significant amount of detrital component are typical for average indicators of the soil cover in the study area, can testify the active introduction of formation which are the results of anthropogenic activity. I said above that we took into consideration the meteorological state of the inside of the study area. This is the average diagram of monthly distribution of the main component of the river suspension and the distribution of iron, some dangerous trace elements in the atmospheric aerosol, river suspension, bottom sediments, coastal sands, and so on. We took into the consideration, I said, the meteorological state, and you see the diagram, a comparison diagram of dynamic of distribution of suspended matter and monthly distribution of the wind speed. Suspended matter tend to change the dimension, mineral and chemical composition and different time intervals. It depends on number of external influences, which are associated with biological cycles, the distribution of the wind's velocity through the year, the duration and frequency of precipitations, and so on, the snow cover, and so on. And the maximum concentration of pollutants tend to find disperse fraction. So the obtained data indicate a significant influence of meteorological industry on chemical composition of air and Dnieper River suspension within the Zaporizhzhia region. We compare the iron containing particles in our samples with the matter from the filtered from enterprises of meteorological industries. This comparison showed that the most active inflow in the environment occurred due to the preparation and smelting of iron ore. Each type of process emission at the enterprises of the meteorological complex of the city is characterized by different types of solid particles. And morphological characteristic of this particles which we sampled of the and each particles of technological component in suspension made us possible to determine its genetic affiliation to various technological processes for preparation, processing of iron ore in that enterprises. Besides, we found some diatom valves, not only in suspended river matter, but also in the samples from atmospheric aerosol. It's a valve of Coconis valve and its chemical composition. What I should mention, I represent you the results of our study till 1991. Last year, due to the war in the Ukraine, we restart our examination only in May, because the part of Zaporozhye region is occupied by the Russian Federation. But the primary research which we obtained last year revealed a number of interesting changes in the intensity of sediment substances accumulation and its component composition. We believe that after our victory, we can continue our examination and more high level. Dear colleagues, thank you for your attention and your support. And this is some pictures, some images from the Blossom Spring Kiev. Thank you again.
Thank you, Hanna. Thank you very much. And the next presentation is early Holocene transgression in bays and lagoons, the Black Sea Northwestern Shelf, Олександра Ольштинська, Юлія Тимченко, Institute of Geological Science of the National Academy of Science of Ukraine.
Just a moment.
Okay.
Где твоя презентация? Just a moment. Надо войти сначала сюда. Где твоя презентация? Где она тут? Где она? Sorry, colleagues. Где она тут? Где она? Сейчас, подожди. Закрывается. Она открытая, но почему-то не будет раскрыта. Не идет? Сейчас.
Юля,
Да.
можливо, я завантажу і буду гортати презентацію вашу,
Давайте,
якщо
да,
є,
давайте.
давайте,
Давайте.
якщо є проблема.
Да, будь ласочка.
Зараз, тепер нам треба 1 minute. Юлія, можемо починати. Юлія, можемо починати.
Да.
Please,
I'm
Юлія,
ready.
please. Будь ласка, Юлія.
Sorry. I want to present our research about paleoceanography of the Black Sea. Our research is aimed to studying the paleoceanographic environments in the Ukrainian part of the Black Sea northwestern shelf and continental slope based on diatom analysis. Diatoms are unicellular photosynthetic organisms that live in any aquatic environment. Due to their sensitivity to change in environmental parameters, diatoms make it possible to reconstruct paleoceanographic conditions such as temperature, salinity, hydrodynamics, and others. Next, please. There are selected several studied areas for a demonstration. In the upper part of the continental slope, the first site, in the inner part of the shelf, the second site, and the coastal zone, the sites 3 and 4. Next, please. The environmental conditions of the modern Black Sea littoral and sublittoral were formed as a result of the early Holocene transgression. The paleoceanographic conditions in the late Pleistocene and Holocene changed significantly and rather rapidly during the New Euxinian transgression about 10,000 years before present. This ecological transformation is clearly seen such in the shallow area of the modern shelf as in the deep part of the sea. In the pictures, you can see a modern Black Sea and the New Euxinian Sea Lake, about 12,000 years before present. Next, please. Our studies showed that the New Euxinian and Holocene environments can be determined by the taxonomic composition of diatom associations and the ecological features. For the site 1, in the deep sea area, transgressive event caused a shift from brackish freshwater sedimentological conditions of the Geociencias Sea Lake by modern marine ones. For the sites 2, 3, and 4, in the coastal part of the sea littoral, the progressive rise in sea level has led to mosaic combination of lagoon marine, estuarine, and marine sedimentological conditions in the shelf zone. Next, please. For the first site, late Pleistocene brackish water lacustrine diatoms were studied from the bottom sediment core 84, located within the continental slope of the Black Sea northwestern shelf. At the end of the late Pleistocene, an endemic taxonomically homogeneous brackish water diatom flora developed within the basin of the Black Sea Lake. Next, please. Due to the dominance of two brackish freshwater species of the genus Stephanodiscus, it is called the Stephanodiscus horizon. Now it is a biostratigraphic marker of the new Euxinian sedimentary top. In two pictures, you can see two species of Stephanodiscus genus, characteristic for the new Euxinian Black Sea Lake. The Stephanodiscus horizon can be traced throughout the late Pleistocene sediments within the Black Sea in the shelf and continental slope, which indicates a little difference in hydrology and salinity. Next, please. The constant component of the complexes is such species as Avlocosera granulata, Panthuchikiella kitzingiana, Ellerbecia arenaria, Diplones dembletensis, Rurella libril, and other. These taxa are indicators of predominantly brackish water, moderately cold water conditions. The complexes are characterized by the dominance of plankton. The new species, Cimatoplevra euxynica, is one of the benthos components. In our opinion, this species is a new marker of the Black Sea upper Pleistocene top. Next, please. Site 2. The Holocene transgression had an effect on the coastal plain of modern Northwest Shelf. In core 60 and 1, the upper new Euxinian deposits are successively replaced by Holocene ones with typical lagoonal marine diatoms. Their diatom assemblages is taxonomically diverse with large-sized walls. It showed that at the beginning of the Holocene, there were conditions of a lagoon or bay with the development of epiphytics and a good preservation. Next, please. You can see a characteristic datum assemblage of the lower Holocene sediments in the northwestern inner shelf. Groups of brackish water marine epiphytes and epipylon dominate. The presence of a significant amount of marine plankton indicates a depth of more than 5 meters and free water exchange. The early Holocene assemblage composition indicates its formation in the calm shelf conditions with low hydrodynamic. According to datum data, after the early Holocene, lagoon conditions changed to an active hydrodynamic regime and sea level rise with the predominance of marine plankton. Next, please. We have chosen two sites of the northwestern shelf, site 3 and site 4, which in the early Holocene represented a coastal plain drained by some rivers. Gradual salinization of limans and estuaries led to successive changes in the composition and ecological features of datum assemblages. Site 3, the Paleo-Kalanchak Valley, now northern coast of the Karkenit Bay near Jarelgach Island. Site 4, the Paleo-Dnipa Valley, now an open part of the northwestern shelf. The presence at this time in modern shelf sites of the river valley or estuary and liman or pond is confirmed by lithological data. Next, please. Sediment course 334 located in the Karkinit Bay, the northwestern shelf of the Black Sea, site 3. Two sediment cores were taken from a depth 13 or 14 meters in the northern part of Karkinit Bay near Geralgach Island. Based on the vertical sequence of datum assemblages, a change in the near shore environment conditions is traced here. Next, please. For the site 4, for the reconstruction of the Black Sea coastal environments, the method of quantitative datum analysis was carried out. Based on the factors life form and salinity tolerance, the results of the datum analysis were synthesized in the form of percentage diagrams for geological groups. The paleoceanography interpretation is based on the trend of relative abundance of ecological groups of diatoms. The vertical succession of the diatom ecological groups made it possible to reconstruct the vertical regressive transformation of paleoenvironments in the Karkinit Bay northern coastal part. Next, please. All the late Pleistocene epiphytic life on microphytes. They are characteristic of shallow low dynamic environments with low range of salinity, freshwater lagoon, and lakes. This for the site on Kalanchak River. For the site on Dnieper River, ecological structure and diatomic compositions indicate the conditions of liman or lake or pond with a salinity of up to 2 per mile and a depth of more than 2 meters. Next, please. In the early Holocene, these sites present the lower part present some assemblages with a mixture of epiphytes, epipelon, and aerophilus. Such ecological groups can be found in shallow ponds with low salinity and periodic flooding. Diatoms show a gradual disappearance of freshwater species from bottom to top. Next, please. In the early middle Holocene, in these two sites, we can see marine brackish pelon. There are characteristics of shallow lagoons and estuaries. These ecological groups occur in mud flats with shallow clear water. In the littoral, datum assemblages are characterized by disappearance of freshwater species and appearance marine ants in plankton. In the picture, we can see the early middle Holocene diatoms of northern shores of the Karkinit Bay. Next, please. The assemblages, datum assemblages of the late Holocene in two sites characterized by marine plankton. Major autochtonic groups is marine brackish epipelon. Next, please. This is characteristic datum complex of the northern shores of Karkinit Bay. Characteristic for now shores. And next conclusions. The ecological structure of studied datum assemblages made it possible to characterize the natural conditions in which the sediment accumulated with the micropaleontological material. It indicates salinity of the basin, depth, illumination, currents, water transparency, etc. According to our studies, 3 levels of the upper Pleistocene and Holocene deposits in the Black Sea northwestern part have clear and recognizable paleoceanographic markers. The first, about 12,000 years before present. On the inner shelf and continental slope, the coastal part of the late Pleistocene New Euxine Sea Lake is determined by the distribution of a specific diatom complex. It is characterized by the predominance of brackish freshwater species, such as Stephanodiscus robustus and Stephanodiscus rotula, as well as the endemic Cematopleura euxynica. These taxa are indicators of predominantly brackish water, moderately cold water conditions. And next, please. The second, for the modern shelf zone, there are brackish freshwater riverine or lacustrine associations were widespread in the rivers and lakes of the late Pleistocene coastal plate. At the beginning of the Holocene, they were replaced by assemblages of shallow ponds with low saline water, irregular flooding, and a gradual disappearance of freshwater species. At the same time, at the beginning of the Holocene, lagoonal diatom associations were formed in the northwestern coastal littoral in the conditions of a low dynamic hydrological regime. And the third, for present assemblages. After the early Holocene, the coastal part of the northwestern Black Sea changed with a gradual rise in the sea level and an increasing in salinity. On modern diatom data, there are conditions of marine littoral in the mid-late Holocene with water salinity of 15-17 per mile. Thank you for attention. Thank you. Sorry.
Thank you, Julia. Maybe a question, maybe conclusion.
Okay, has anybody any question? Do you have questions? Yes, of course. I expected that. Please.
Thanks, Santi. I would like to thanks first of all to the 3 speakers of today. My name is Encarni Montoya, and I'm one of the researchers at here at the Institute. And if for me, I mean, I'm also a paleoecologist, so I enjoyed every single slide of your 3 presentations. Thank you so much. I would like to start because I have so many questions. Asking to Sergey and the third speaker was called Julia, sorry?
Yes, my name is Julia.
Alexa, okay. So I would like to ask you both, because you've been both working with sediments, and I was wondering if you have had the chance to date to some extent some of the sediments that you have worked with, or if you have an idea or a biomarker or another technique to know about some potential ages of your records. Thank you.
Thank you for question. We use datums for reconstructions in our paleoceanographic, paleogeographic researches as main method, datum analysis.
Yes, is it possible? I also want to say some words. Actually, we expect to make some datings for our samples, and now we have these samples in Kiev in Institute, and now it's only some questions of equipment and where we can find the laboratory to make these datings. So we expect that maybe in the nearest time we will make this work also, and we put that information in our documents also. But
Fantastic,
maybe in
thanks.
future. Mhm.
Can you
We
can you
have
hear
no,
us?
we have no absolute dating.
Not yet.
Perfect, thanks. Can you hear
We
us?
have a stratigraphic material, and we research our datum complexes and dating our data by these complexes approximately.
I'm Santiago Giral, the director of the Institute. I really want to thank you all for your really interesting talks. I really enjoyed as well your talks, because I'm working in Quaternary in Holcim, but in lakes, not at the sea. And I really enjoyed your talks. And that's one of the questions I wanted to ask you, Sergey, about the radiocarbon dates you want to perform. You want to perform from the complete sediment sample, or will you try to extract the organic matter? Because, well, I work in Antarctica as well, but a little bit north of you. I work in the Shetlands, and it's a nightmare to date the sediments in Antarctica, because you have this huge reservoir effect, and it's always very, very difficult to date them. So I'm really interested to see your results, because it's always a nightmare to achieve really good radiocarbon dates.
Yes, you're completely right. Yes, and that's why now we can't make that, and we expect that maybe in future, after our victory, we can focus our attention on that work and prepare everything properly to make good datings. That's why now we can only make some interpolations with connected areas and with some published data. And that's why I understand you very well. It's really very difficult to work with that samples, and especially to extract that organic material to dating.
Yeah,
Yes.
because the productivity is so low that the organic matter content is always very low. It's always less than 1% or less than 2%, and then you need a lot of sediment for dating, and that's a nightmare. It's a nightmare. Good luck with that, because it's always very difficult to achieve good results. I would like to ask to Marina about your anthropogenic particles. I'm sorry. Anna, sorry, Anna.
Yes.
I want to ask you about these anthropogenic particles, because it's really interesting. I really love this presentation, especially because you can trace perfectly well the contamination, the human contamination, and you showed two main particles, no, iron and aluminium particles. Have you seen carbonaceous particles in your samples? Because I wanted to see, well, usually you can expect that from high combustion. When you burn fuel, usually you have these spherous carbonaceous particles, but you have not shown them. Have you seen them in your sediments?
No, the main particles are iron spherules and aluminum silicate spherules.
Only ones. These ones. It's really curious, because I always studying sediments here in Spain. You can see them, and it's quite common to see them. So it's really interesting, your results. Have you tried to identify these particles in the sediments to see how these evolved through time?
No.
That's a
it's-
really interesting thing to perform, because you can see when the contamination starts. No, if you take a core in the Dnieper River, no, using fine sediments, you can really study the temporal evolution of these particles, and it's really interesting to achieve that.
Yes, of course. I think it will be the next step of our examination further. Thank
Okay,
you for your-
so then I'm really interested on that, because it's always really nice, no? Because you can see not only the industrial contamination, but the historical contamination related to the Romans or whatever you have around that, and it's always interesting to study that. So it's a really nice study that you are performing.
Thank you very much. Thank you.
And no, indeed. And I want to ask a question to Alexandra about this transgression in the Black Sea. And Alexandra, you said you have no radiocarbon dates.
My name is Julia.
I'm sorry. sorry. Yeah. It's the computer. The name of the computer appears as
Yes, I see. Yes.
I'm really sorry, Julia. Sorry. You said you have no radiocarbon dates, right? In your sediments?
No.
Okay.
We have not.
But I imagine that the changes you see in diatoms are very rapid, no? Because during the early Holocene, when you have the glaciation, I imagine the main rivers providing water to the Black Sea, no, the Danube and the Dnieper, started to provide huge quantities of water at the beginning of the Holocene. So the Black Sea level rose very fast, I guess, right?
Our research demonstrate that the transgression, Holocene transgression, Upper Pleistocene Holocene transgression is not very fast. It rather gradual, and the diatom assemblages of rivers or lakes gradually changed on firstly assemblages of ponds and marshes, and so of marine contemporary marine assemblages. It's not very fast.
That's it's surprising, because I thought, I don't know the area, but I thought that when you have this deglaciation, when the ice caps disappeared from Central Europe, no, I imagine that provided a lot of a huge quantity of water to the main rivers, like the Danube, no? So the sea level, the Danube, the Black Sea level, sorry, rose very fast. But you are saying how many years took to these transitions takes? How many? What's the period of time you see between one stage to the other one in this transition, this transgression? For how long did it take?
On our data, the transgression on the shelf in Black Sea shelf was during 10 to 6,000 years approximately.
Okay, no, it's really slow. I thought that it was much faster. No, it's really interesting. No, really, I really enjoyed the three talks. No, really, I really enjoyed. You are doing a really nice science. Really, it's really good. Wait, and Karen has more questions.
Sorry, just one more question. To Anna, please, about the second talk. I was wondering, because the data set of modern, I mean, the monitoring that you are doing is very precise, or that you have done is super precise and very frequent sampling. So I was wondering if you are thinking or building a transfer function for this comparison to the sedimentary cores that you have and Julia has shown and even extrapolable to other places. Are you considering to use this modern data for building a transfer function to find the starting on the anthropogenic disturbances in the sedimentary archives? And if so, have you heard of the pages working group called Human Traces? Because I'm sure that they will be very interested in this data set and collaborating with you. Thank you, and that's all for me. And thanks again to the three speakers.
Thank you very much for your question. Now we concentrated to examine the suspended matter of air, from air and from the river suspended matter. We don't have an opportunity to examine now the bottom sediments. When the situation will stabilize, we continue and took into consideration the examination of the bottom sediments of the Dnieper River. Thank you, but now we don't have the cooperation with other colleagues from Europe or from Ukraine in this subject. But thank you for your support of our work.
Thank you. Thank you very much, my Ukrainian colleagues, for very, very interesting presentation, reports, speeches. I know that my Ukrainian colleagues live and work in very, very difficult conditions. Thank you very much. And I'm happy that my Spanish colleague give opportunity to organize this cycle of conferences, because I am sure that this small conference will build big, huge, very interesting collaboration between Ukrainian and the Spanish geologists. I'm sure. Thank you very much.
Thank you very much, and on behalf of Ukrainian colleagues, of all my colleagues, thank you very much for organizing this meeting. Thanks, Anna.
Thank you.
Thank you very much.
Thank you very much. Thank you.
Thank you.
Nice to see you. Bye.
Marina, glad to see you. Дякуємо.
I'm glad to see you, all my colleagues
Thank you.
too.
Bye.
Thank you.
Bye.
Ганна, the Ганна question I have. Ганna, do you admit cosmic genesis your spheres?
As for chemical analysis, it's anthropogenic.
Chemical analysis.
Chemical
show.
analysis.
Да, this region is very
Anthropogenic load.
anthropogenic vets.
But Marina, we met these rules of cosmic genesis during our investigation in Crimea.
Thank you. It is a very industrial region because
Yes.
A lot of pollution in the air. Yes, I understand. Thank you. Excuse me.
See you.
No, bye.
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 Bye. Bye.
See you.
Bye.